Okay, so what we're going to do here is we are going to find the probability of hitting the blue area. I made it darker so you guys could see it. With that, we need to find the total area first. So with each one of these problems, we need to find the area of the shaded region, round the answer to the nearest hundredth if necessary. Then find the probability that a randomly chosen point in the figure lies in the shaded region. Essentially, find the total area, subtract some stuff, find the shaded region, and then what's the probability of hitting the shaded region. So to start, I have a circle that is large and then a smaller circle that is cut out. With this larger circle, from the center to here is 5 because half of this diameter is 5, and then this extra length from the ring on the inside to the ring on the outside is 2 feet. So the radius of the big circle equals 7. So the total area is pi times 7 squared, which equals 49 pi. And I'll do the labels at the very end. I don't care about them at this exact moment. So that's the total area. When I subtract this inner circle, that will give me the ring on the outside. So let me get my pencil lead here. There we go. Maybe, there we go. Cut out equals pi times 5 squared, which equals 25 pi. So if I take 49 pi minus 25 pi, that leaves me the ring. So the ring equals 49 pi minus 25 pi, which equals out to be 24 pi. So based on that, that's this cut out ring here. And I see that this ring is marked into 4 equal parts, so I have 1, 2, 3, 4, and I want 2 of them. So I'm going to take 24 pi and divide that by 2, which equals 12 pi feet squared. That's the area of the shaded region. Now, to find the probability of hitting that, I'm going to take the total of 49 pi. So what's the probability? 12 pi divided by 24 pi equals out to be, 49 pi. Let's try that one again. 49 pi equals 12 divided by 49, which equals a percentage. I'm going to do that, oops, sorry about that. Percentage down to 4 decimal places because I want it to be hundredths when I round. So 12 divided by 49 gives me 0.2449, which is 24.49%. Alright, so the next one, total area is going to be of the circle. Get this moved up just a little bit more. There we go. So the total area is going to be the circle. The diameter is 6, so the radius is going to be 3. So the total area, pi times 3 squared, which equals 9 pi inches squared, if you're worried about the label. So that's the total area. Now with the total area, I got to do the cutout. So looking at this, I have 1, 2, 3, 4, 5, 6 sections, which means if I go across here, that's 3 sections. So 1.5 this way, 1.5 this way. The base of this triangle is 3, and the height from the center to the edge of the circle is 3. So the height of the triangle is 3, the base is 3, so 1/2, 3 times 3 equals 4.5. That's the area of the top part of this triangle. So this top triangle, and then I want the bottom one, there's 2 of them exactly the same. So 2 times 4.5 equals 9 inches squared. So the shaded region is going to be 9 pi inches squared minus 9 inches squared. So 9 pi minus 9 is approximately 19.2743 inches squared, so that's the shaded. And then what I'm going to do is I'm going to take shaded divided by total. So I'm going to take 19.2743 divided by 9 pi. That gives me 0.6817 inches squared. Not inches squared, excuse me. 0.687, which is 68.17%. On to number 27. On this one, I am given the hypotenuse of the triangle on the inside. Also, I know that this is a special right triangle. 360 divided by 3 sides equals 120. Divide that by 2 equals 60. So since this is a special right triangle with this degree here being 60 degrees, hypotenuse, this is my short leg, which is 5 root 3. Or you can do trig. If you did trig, you would have to do sine of 60 equals x over 10. This would be x. And cosine of 60 equals a over 10, and this would be your apothem. But because I know it's a special right triangle, I'm not going to do that. But if you were, that's how you would do it. So apothem is 5. Side length is going to be double this, so 1/2 5 times 3 sides times 10 square roots of 3, because if I double 5 square roots of 3, it's 10 square roots of 3. So multiplying this out, gives me 75 square roots of 3, which is approximately 129.9038. That's my cutout. To find the total area, pi times 10 squared equals 100 pi. So I'm going to take 100 pi minus 129.9038. Shaded area is 184.2555 inches squared, so 184.26 inches squared with rounding. To find the probability of hitting that, I take 184.26 divided by 100 pi. I get 0.5865, which is 58.65%. Alright, that's the first 3. So moving on. Each one of these markings is congruent and they're all worth 1 millimeter, or excuse me, 1 meter. So my total big circle, so largest circle equals radius of 4. The next one's going to be 3, next one 2, next one 1. So the way that this one works out, to get the shaded area, you have the big circle that's shaded, which is pi times 4 squared. And then what you're going to do is you're going to cut out the next circle, which is pi times 3 squared. Then what you're going to do is you're going to add back the total blue circle, which will be a little bit smaller here. And what that does is adds that circle to the ring that you had left. So when you take the big circle minus the cutout, you're left with the ring, and then what we do is we're going to add that part back in. And then I'm going to take of that inner ring this part here, I'm going to cut out pi times 1 squared. So this is going to be 16 pi minus 9 pi plus 4 pi minus 1 pi, which gives me 10 pi. So my total area is 10 pi meters squared. You can leave it like that, or you can give me the decimal representation of it, which is approximately 31.42 meters squared. And then to find the probability of hitting that would be 10 pi over 16 pi, because your shaded area is 10 pi, your original big area is 16 pi, which equals 5 over 8, which is approximately 0.625, try that again, which is 62.5%. Alright, moving on to number 29, you know a side length. So since you know the side length is 16, your apothem is unknown, your radius is unknown, but I do know this is 8, and then out of the math, 360 divided by 6 gives you 60, divide that by 2 gives you 30. I know this is another special right triangle. Since this is a special right triangle based on 8 being here, you would use tangent of 30 equals 8 divided by apothem. And to find your radius, you would use sine of 30 equals 8 divided by your radius to find the missing parts. But since it's a special right triangle and I know that this is my short length, radius is double, so my radius equals 16 as well, and my apothem equals 8 root 3. And because I already know that, I'm just going to do the math. So total area equals 16 squared pi, which equals out to be 225 pi. No, let's try that one again. 16 squared is 256. To find the cutout, 1/2 the apothem, which is 8 root 3, times 16, because that's my side length, times 6, approximates out to be 665.1075. So 256 minus this, 256 pi minus 665.1075. So the shaded area is approximately 139.14 units squared. 139.14 divided by 256 pi approximates out to be 0.1730, so 17.3%. Now on number 30, there are 3 of the 8 equal parts highlighted, so yes, 3/8, which equals out to be 3.37.5. However, if these weren't equal, or if you had different degree measures on your arc lengths, you'd have to actually figure out the area of the sector, measure of the arcs, excuse me, and so you'd actually have to find the area of the sectors. So 360 divided by 8 equals 45. So each one of these arcs has a measurement of 45 degrees. So what I'm going to do is I'm going to find the area of one sector, then multiply by 3, and then divide by the total area. So 45 divided by 360 equals x over pi times 13 squared. This is my total area. Okay, so 360x equals 45 times 169, 706.05 pi. I'm going to divide both sides by 360. I get x equals equals 21.125 pi. So if I take that and I times it by 3, so 3 times 21.125 pi equals out to be 63.375 pi. And if I divide that by 169, so 63.375 pi equals the shaded area, which is approximately 199.10 inches squared. And if I take that divided by 169 pi, I get 0.3750, which gives me the 37.5%. And I apologize for not showing that up there. So with this, you just got to make sure that you know what you're being asked for and be able to find anything at any time. Now, mind you, 28 is really important, 29 is really important, 27 is really important. You need to know how to find areas of circles that are tangent and squares, and you just have to look at the picture and understand what is being given to you. Understand what a diameter is versus a radius. Good luck on your last part of your test.